In the last videos, we've described ways to represent the preferences of consumers, such as the utility function and indifference curves. And we have described the budget constraint that describes the feasible consumption bundles for the consumer. Now, in this chapter, we put the things together and describe utility maximization. In this chapter, the graphical approach, and later on we will discuss the mathematical approach and some examples. The starting point for the chapter is the question of how an individual should choose its consumption such that it gets the best out of the limited budget that is available. And that's a choice we face very, very frequently in our lives. From a formal perspective, we can solve a utility maximization problem to get this choice. And to do this, we will first discuss a very intuitive graphical way to solve this utility maximization problem, and then in the chapters afterwards discuss the use of the method of Lagrange to determine this from a mathematical perspective. Now, graphically, we start by depicting two different goods on the horizontal axis x1 and on the vertical axis x2. And we have the budget line that describes the feasible set for the consumer. So the budget line has this slope here that's given by the relative prices of the two goods. Everything that is to the left of the budget line is feasible, can be bought with the budget that the consumer has, and everything to the right here is not feasible. The next that we need is a description of the preferences of the consumer. And we can do this with the indifference curve, where I depict one of the possible indifference curves here. We know along this curve, the consumer is indifferent between all the consumption bundles that it can choose from along this curve. Now, a consumption bundle here would not be feasible. It's outside of the budget set. The same holds true for a consumption bundle here. But there are different consumption bundles within the budget set that are all feasible and among which the consumer is indifferent. So this could be, for example, this point here, 20 units of consumption of X2 and 6 units of X1. Or this bundle here with a lower level of X2 but a higher level of X1 in exchange, and so on and so forth. However, from this graph, it's already obvious that the consumer could have done better than choosing any bundle on this particular indifference curve, because you could move to a higher indifference curve and still choose a consumption bundle that is feasible. Now, what's important here is, of course, that we do not have a dynamic optimization problem where you could save and then consume in the future so that you leave money on the table, but it's just a static one-shot consumption choice. So leaving money on the table would be something that reduces your utility, basically. So if you spend more but still stay inside the budget set, that would increase your utility or shift the indifference curve further away from the origin, which is the same thing. And by the same argument, we could find another indifference curve that is higher than this indifference curve still, right? And this goes on until we have an indifference curve that only has one single feasible consumption bundle, where this indifference curve touches the budget line. So at this point here, this would be the highest indifference curve that the consumer can reach. And on this indifference curve, there is exactly one point that the consumer can still afford. All the other points along this indifference curve would be in the set that is not feasible. And utility maximization now means that the consumer searches for exactly the consumption bundle that leads to the indifference curve that is farthest away from the origin, but still feasible. So that's the point that leads to the highest attainable utility level. And the good thing is that at this point, a few properties hold that can help us to solve for this particular consumption choice. And that is that at this particular point, the budget line is actually a tangent of the indifference curve. Why? Because exactly at this point, the slopes of the two curves have to be the same because they need to touch each other, but no other point along the indifference curve must be feasible. So then it's exactly at this point where the two curves have the same slope. The slope of the indifference curve is the marginal rate of substitution, and the slope of the budget line is the negative of the price ratio of the two goods. And setting these two equal to one another allows you to solve for the consumption bundle that leads to the highest utility level and is still feasible. So we can summarize the graphical analysis of the utility maximization problem as such that the consumer strives to find the consumption bundle that it likes most among all the bundles that are feasible. So this bundle will then lie on the budget constraint and on the indifference curve that is associated with the highest attainable utility level. Along this curve, all other points would lie outside of the affordable set, except the one that is on the budget line, and that is the optimal choice. So this choice selects out of all the feasible choices the one that the consumer likes most. And that's arguably describing the behavior of most consumers very well, right? So we want to buy the goods that we like and that are still feasible. And at this point, at this optimal choice, the budget constraint is the tangent of the indifference curve, where at this point the slope of the two curves is the same. So the indifference curve, the slope of the indifference curve is the marginal rate of substitution. The slope of the budget constraint is the negative of the price ratio. And at the optimal choice, these two have to be the same. So we can use this result to derive the optimal consumption bundle in standard ways, or otherwise we can just use this graphical analysis and get to the point in a graphical way. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.